In this video, we're computing the integral of secant squared x over 1 plus tangent x on the interval 0 to pi over 4. And the quick way to do this one is just to recognize immediately that the derivative of the denominator is sitting in the numerator. So remember, the derivative of tangent x is secant squared x. Well, this is exactly what natural log functions do. I can immediately recognize that this is the natural log of the absolute value of that denominator. And then we have to evaluate from 0 to pi over 4. Now, if I investigate the lower limit real quick, that's 1 plus tangent 0 inside those absolute value bars. Well, the tangent of 0 is 0, and that gives me the natural log of 1, which itself is 0. So when I sub in that lower limit, I get a 0. All I have to worry about is the upper limit. So I get a natural log of 1 plus the tangent of pi over 4, and the tangent of pi over 4 is just 1, so I end up with the natural log of 2, and that's our answer. Now, just a quick reminder, if that solution seemed too abrupt, when I take the derivative of a natural log of some function, so we'll just call that f of x, I take the derivative with respect to the interior function. In other words, I treat f of x like a single variable first, and I get 1 over f of x. And then the chain rule says I have to multiply by f prime of x. And this is exactly what I recognized in the integrand. I saw the derivative of the denominator sitting in the numerator, so I was able to quickly guess the antiderivative as a natural log. Now, if you want to handle this with a standard u-substitution, you still have to basically recognize what's going on here, that the derivative of tangent is sitting up there in the numerator. So the alternative approach here with an explicit u-substitution would be to say let u equal that entire denominator, so that's 1 plus tangent x. That means du is secant squared x dx. That's the part you kind of have to see coming in order to make a productive u-substitution. I have the secant squared x dx there already. I'll go ahead and transform the limits of integration while I'm going here. So when x is equal to 0, u is equal to 1 plus the tangent of 0, which is 1. And when x is equal to pi over 4, u is 1 plus the tangent of pi over 4. Again, the tangent of pi over 4 is 1, so I get 2. And now my integral is transformed to the integral from 1 to 2. Of 1 over u du, and this gives us the natural log of the absolute value of u, evaluated from 1 to 2. So I get the natural log of 2 minus the natural log of 1, but again, the natural log of 1 is 0. So we arrive at the same answer, natural log of 2, and we're done.